Hello and welcome to session 3 of our coding with Python and Pictoblox. And in this session, we'll be going through another interesting activity just as we had for session 1 and session 2, where we developed our loan calculator and then our maze game for session 1 and session 2 respectively. So this is session 3, and in session 3, we are going to program what we call real-time phase detector. So our real-time phase detector, just a little overview, is supposed to do 3 things. The first thing is it should turn on our camera. The second thing is it should detect the phase. And then the third thing is to detect the expression of the phase and then declare it to us with the help of our sprite. Okay. So now already we have our sprite on stage and then we have our Pictoblox opened. And to get started, we will first of all switch to our Python coding interface. So we click on Python here, go ahead. Okay, and we have our sprite.py library already opened for us. And to continue, let's name our project. And let's say our project is called facial expression detector. Okay. Now the next thing we have to do is to detect the face. Okay, because I mentioned that we have 3 things to do. Sorry, 3 things to do. Turn on our camera, detect our face, detect the expression, and then declare the expression out loud. So let's turn on our camera first. So we need a line of code that will turn on our camera. But before then, we have to kind of call the face detection library. There's a library in Pictoblox, or should I say Python, that we will need to be able to use. And it's built based on the human knowledge of how the human face looks like. So first of all, we have to call that library, and then we'll be naming that library, assigning it to a variable, and then we'll name our variable FD. So we say our variable FD is equal to the face detection library. Okay, so we have this. So since we've gotten our library, now that means we can go ahead and then turn on our camera. So to turn on our camera, now anything in the face detection library we are looking for to use, we'll be using the fd dot expression, and then you call any other library or any other expression we need to add up to it. So to turn on our camera, we'll use fd dot video. So video on, and then comma 0. Okay, so this line of code is simply saying that, okay, we want to turn on our camera, and then so the on is the camera state. So the camera state can be on, it can be off, or it can be on flipped. So on flipped is more or less like it changes the orientation of the image it's detecting. So let's say I use on flipped. What happens is it shows my left as my right and my right as my left. Okay. And then the 0 is simply what we call transparency. Yes. So the 0 is transparency, and it ranges from 0 to 100. So a transparency of 0 means no transparency at all. A transparency of 50 means partially transparent. And then a transparency of 100 means I'm fully transparent. That means our image is fully going to fade off. Okay. So since we have our camera turned on, the next thing we want to do is to get our bounding box. So we have to enable our bounding box. So the bounding box is simply, after we've turned on our video, the bounding box is supposed to kind of bound the face the system is detecting. Okay, so we use fd dot enable box. So fd dot enable box will turn on or enable our bounding box. And then after we've enabled our bounding box, then we will have to go ahead and set our threshold. The threshold is simply the quality of the image we are detecting, or the quality of the face we are detecting. So the threshold values ranges from 0.1 to 0.9, with a 0.1 value being the lowest and a 0.9 being the highest. So with a lower threshold value, you don't really specify the features, so it's easy to detect the face. But then when you use a higher threshold value, that means it is looking out for very specific features of the face. So if you don't really have a quality image, your system will not be able to detect the image. So in my case, my camera isn't really clear. So I would like to use a 0.1 threshold value. But if you have a good camera, you can use a 0.4, a 0.5, or even higher. Okay, and see how this will work. But if I use anything more than 0.3, 0.4, I'll have difficulty detecting the face. So once again, I call my FD variable. So I say FD set threshold. So I'll set my threshold to 0.1. Okay. Now, after I've set my threshold, the next thing I want to do is now to set my conditions under which my program is going to run. So my conditions are, so now the program will detect the face. When it detects the face, what do I want it to do? So it's able to detect a face. So when it detects a face, then I want it to do what? So now be able to read the expression of that face and then output something. So to do this, I will need the while loop, and then I will need a for statement to do this. So with the while loop, so I want to say while the conditions I have are true, then what do I want to do? I want my system to analyze my data, or to analyze the picture the camera is capturing. So I say fd.analyze camera. So fd.analyze camera. Great. And then I'll now bring in my if and else statement. So if what? So I want to check after you analyze the camera. Now check and see if you are detecting any face. So to check if you detect any face, you will need to use a count, what we call count. So you are going to count the number of faces. If you detect a face, you count the number of spaces. So I'm going to say if fd dot count is greater than a 0, that means if you detect more than 0 faces, that means if you detect one or more faces, then what should happen? If you detect more than one face, what should happen? Then I want sprite.say, I want my sprite to say something. And what will my sprite say? So sprite.say fd expression. So what I'm simply saying is that, so first of all, check and see if there are any faces captured by your camera. And yes, if you capture any face, then I want you to now tell me the expression of that face. So the sprite we have on our stage will now have to tell us the expression of the face. Okay, we don't want to use a time or a limit for the particular expression to show on the stage, because it's going to be a real-time monitoring. So at any point in time it detects the face and detects a different expression, it is supposed to let us know the changing expression. We shouldn't keep a particular expression for a long time, even when the expression had changed. So we'll be adding any time limit to keep whatever the sprite sees on the stage. Okay. Okay, now we bring in our else statement. So if it detects, then it should say this. Else, what should happen? So else, want our sprite to say no face detected. Okay, so this is our simple code and we hope it is going to run. So now let's run our code and see what we will get. Okay, so it is loading the models. It's loading the face detection models. It is really keeping a lot of time, but let's wait for it to load. Great. So models loaded successfully. Okay. Now it's running. So we have another error. They are telling us that our camera is already in use. So the system is unable to turn on the camera again. So I'll quickly switch off my video and then allow our code to use the camera. Let's run again. Okay. Let's place stubby here. So neutral face. Happy face. Okay. Surprised face. Let me try to get angry. Okay, so we can see it detecting different types of faces. So we see happy, we see surprise, we see sad, we see neutral. Great. So depending on your expression, then it should be able to tell you. When you get angry, you see angry face as well. So you can try this, change different facial expressions and see what you get. But my facial detection is not constant because I already mentioned I have issues with my camera and that is the problem. But if my camera was bright or clear enough, I wouldn't have faced these issues. So thank you and like and subscribe to this video.